Okay, welcome everybody. I know this has been a very long day. We are going to start, I think, the last panel of the day, and the topic of today is bridging the gap between technology invention and market impact. I am Javier Albares. I am the head of programs of the SNS JU. As you know, the Smart Networks and Services Joint Undertaking is a public-private partnership between the European Commission and the 6GIA that is developing a program focused on the development of 6G. One of the best things that I think I have on my role is that I am able to interact with very bright minds, like the 5 that we have here today. So let me introduce the panel that we are going to have today with our discussion. First, I have Dr. Tong, CTO of Huawei Wireless, and also I think you are the Huawei 5G chief scientist. Thank you very much for coming here today. Dr. also Azimeh Sefidcon. You are the VP of Network Security at Nokia Bell Labs. You made a very interesting keynote this morning, very interesting one. Also, we have Professor Ana Garcia Armada from the Universidad Carlos III of Madrid. Thank you for coming. Professor Petar Popovski from Aalborg University. And finally, we have Stefaan Vyverman, I think I pronounced it properly, who is a member of the Council of the Belgian regulator. BIPT. Thank you also for coming. So let me start with I think just to set the scene on a comment. I think we all agree that 6G and AI are going to have a profound transformational impact on our economy and on our society. But at the same time, it has a lot of challenges, especially for adoption and to guarantee the economic sustainability of the business case that is associated to it. So with this idea of moving research into market reality, going through all the process of designing, manufacturing, implementing the technology, deploying it, and actually making sure that it is used in use cases, I had a discussion same question for the 5 of you, and I would like to frame it properly. Usually, time and scale are the most complicated topics to answer when you are trying to forecast the impact of technology going forward. So with a very specific time point, for example, I don't know, 2032, assuming that it will be 2 years after 6G has been launched, what do you think is going to be the use case that will have, let's say, more impact from an economic perspective in the economy? And I think I would like you to make a bet on that. Hopefully, we can see each other in 8 years' time and look backward and see how accurate we were in our forecast. The logic I'm using is, you know, the famous triangle of 5G with EMBB, massive IoT, and so on. EMBB was really the area where most of the value was concentrated, especially in the initial years of 5G. And I wonder if we extrapolate that logic to the hexagon that is defined in 6G, where do you think is going to be the area of most interest? Maybe we can start with Professor.
Yeah, thank you for the opportunity. I guess we are now in the process from the research and the technology, exploration or validation, testing to the definition of what is a 6G. We come very successfully have a global consensus, which is the ITU definition with 6G. These definitions, it is a very sound one from the industry point of view. Basically, there's a two-part. One is connectivity. So it is a continued evolution of the 5G with the 3 EMBB, URLC, and MMTC. Then the other new part, which is previous generation do not have, is the beyond the communication portion, that is the sensing and AI. These two will be rapidly developed perhaps as a dominant feature for 6G. There are two reasons because the AI revolution is happening. In a very short description, is the AI going to pervasive to everything, any business, and every bit of life of what we do? And then because the AI so far we have is to stay in the digital world. When they have to go apply to the physical world, AI need a very critical step. This is the alignment with every, the precise moment and where the location of it is. That's the sensing is the key. Without sensing, any form of sensing, then there is no, there will be AI, it will become to the physical world will be difficult if it is not possible. So in that case, 6G is the right interface between the digital world and the physical world. So this is the high level. The perspective we can say today, it is very hard to say a couple of years ago because to answer your question, what is the 2030 and 40 will be? I think the major development is in the digital world, and it is very different compared to the mobile broadband. It's the the app-based. So app-based the application probably will soon disappear. Will take over by all the AI service, and that's because the powerful of the digital world as a progress. That's where 6G has to be relevant to this revolution. Otherwise, it won't be not a mainstream, or may even the growth will have the problem with that. I would just.
Thank you. Azimeh, your opinion?
What I would like to add is that I think we still will continue with this two sides of the AI for the network and network for AI. I think in the application of AI, we definitely, of course, it is related and dependent on the data, but data is distributed. Who can actually accommodate for that is the network. So network facilitates either by local processing of the AI agent and AI algorithm, or actually correlating data or transferring the data. That's the easy part of it. And also, of course, when it comes to AI for the network, in every single layer of the network, in every single component that we have, wherever we have had prediction and software and a little bit of more precision also on decision making, we can rely on the AI. So I foresee that we will have, by the time that you mentioned, we will have AI across the entire network, but we really will see the benefit of the network for AI as well. However, we have to see the combination of the AI together with other capabilities, other expectations that we have from the network. So it's not necessarily just to make the network better because we can. Yes, that's good, but I think we can, the AI, combination of AI and service creation, but also AI, for example, for application network, semantic communication, actually learning what the application needs from the network. These are going to create new wave and new possibility for the network that we have not had today. So I really look forward to all of that.
Thank you. Anna, from a professor perspective, where do you see the most important area?
Yeah, well, good afternoon, and thank you very much for the invitation to the panel. You asked for one use case out of the 6 that are, foreseen, but I'm going to reply with 2. Sorry about that. Because one is, what I think is the most important, but maybe not the most important in terms of market. And it is the ubiquitous coverage, which I cannot believe we are not still there. I mean, I don't know why we are not still there, but I think there is still technology to develop, but I think there is also some willingness to be there, right? And I'm not talking only about the other 2 billion that cannot connect to the internet, but I'm going to tell you that on Saturday in Madrid, I was attending a concert. It was a little bit outside Madrid, but it was a populated area, but not so populated to have a lot of usual traffic, and there was no coverage. And of course, coverage there was. There were not availability, but people were complaining about coverage, but the towers were there, it's just we didn't have enough channels. And I was wondering, why doesn't Vodafone come with the drone? I mean, they have it, I've seen it. So I wonder what is happening that we still cannot provide coverage everywhere. And well, if we need to wait for 6G, let's wait for 6G, but hopefully it will come. But now, market-wise, and I don't think there is not a market for this, but maybe, you know, there are other people that cannot really pay a lot. Market-wise, I think it is the immersive communication. Why I think that? Because I think 6G is going to be as usual. You know, usually we have the odd generations that start something for the early adopters, and the even generations that generalize it. And I think in 6G we will have we will make available something different for the people that, you know, they are, I think, a bit disappointed because 5G they didn't see like a big advantage. I always tell them, wait, because 5G has to be deployed until 10 years. But I think we will probably see in 6G the immersive communication that is going to change the way, radically, the way we communicate. And that would be a revolution for the user. And I think users are waiting for something exciting, and I think it could be that.
Peter?
Yeah, thank you, Javier. It's a couple of things, but I will just mention two. One is that the device that really changed mobile communication appeared 17 years ago, right? It was the smartphone, and compared to the other phones, it didn't have a keyboard, right? So people from BlackBerry didn't believe in a phone without keyboard and so on. So maybe it's the time to ask what is the new device that is going to appear in the coming years. And some hypothesis that I have from all I see and all I hear from the other panelists is that maybe now the sensing will remove part of the device from the user because part of the functionality will be at the network side. So the missing keyboard is maybe some of the other functionalities we have, my pen on the iPad and so on. Maybe that will disappear in the new device and be part of the sensing. So that's the first thing. And the second, I think this integration with non-terrestrial networking is an important one, because if you take an average user on the street and you say that the phone has a FR3 spectrum, they don't care. But if you say that the phone is connected directly to satellite everywhere, then everybody understands. So these are maybe two things that are, let's say, visible also to the users.
Thank you. We will get back to that in a minute. Stefaan, what do you think?
Yeah, well, as you said, it's a difficult question, because at this point, I think we are still looking at what's the killer application for 5G even to make it really profitable, especially in the B2B environment. But if you look back, I think 10 years, what they then said about 5G, what is now the reality is totally different. For instance, in the businesses, what I see is as an entrance toward private networks, the main application there that is looked for is mission-critical communication. What I think was 10 years ago, not really the main topic where everybody was talking about. So it's also about, and the reason that technology comes forward, because it's that old technology there, Tetra, is end of life. They have to change it. It's with investment cycles. So, and therefore, 5G is here at the right moment for mission critical. Now, how this will be over 10 years for 6G, to be honest, I have no clue. But if I have to put my money on something, I would say that augmented and virtual reality certainly has a very good chance to be a winner here.
Okay, now going back to the initial question, if we place ourselves in 2032 and we go backwards towards today, what are the technical challenges or regulatory challenges or economic challenges that for each of the use cases that you have defined as the most relevant ones need to be overcome? So what are the things that you need to believe for that to happen?
Yeah, so I think technology will continue to disrupt any prediction or any plan, even business plan because this is 8 years is too long to plan that future. But it will be remaining the market will still drive the usage and the technology to that time frame. The most powerful one up to date is the AI. And then there will be to which extent AI will develop the capability. In 2 years, there was a artificial general intelligence will show up, and then there will be start to have a super intelligence. But then those will be still in the form of digital computing will be extremely power hungry. So there will be power limited at a certain point to do that. But then this is one limiting factor. The second is how well we can technically understand and regulate this artificial intelligence, because there are many side effects or risks associated. So these are the one that will determine how far AI will go. And of course, there will be this ecosystem imbalance of this, because it consumes a big computing availability, data as well. So these are the potential factors that will come into the play.
Yeah, I think I would start with focusing on the data and data privacy, because it will be impossible to do anything without that. And the sharing of the data, I think the question of anonymization of the data is already there, and it's possible to do, but still the regulation are who this anonymous data belong to. I think there is some work to be done there to make it possible to share knowledge. But also, I think the exchange of the data should be more dynamic than it is today. And for that, you start to think about the handshake and trust relationship built dynamically as well. So we need a little bit of protocol design for that. But these are all feasible things to do, but they are not all geared together. So all of these platforms that actually make it possible, I use the word platform for us to just refer to combination of many different elements that needs to be in place to make all of these use cases of AI possible.
And for your two use cases, what is needed?
Talking about technical challenges, I think there are a lot, because essentially we don't know how to do it, right? So we want to do jointly somehow communications, computing, sensing, and control. Because if we don't somehow find a paradigm to do everything together, it's going to cost a lot of energy. And most likely we will not have the resources, for example, to do jointly the sensing and the communications in both use spectrum, and we don't have enough, right? So we need to find out how to do this jointly, but we don't even theoretically know yet how to do this in a good way jointly, right? Because the paradigm of communication has been for a long time, just transmit bits, do not worry about what these bits contain. And now we need to change that. And it cannot be just, in a couple of years, because it took us very long to arrive here and to understand so much we understand right now. So even we don't know how the modulation has to look like if we need to do all these things together, and how to plan, multiplex all this, right? So I think technically there is a lot of challenges, and this is what is exciting, right? Because we like challenges, and there is a lot to do. About other kind of challenges like socio-economical or regulation, I think it is extremely important to take into account the user, because they need to accept these technologies, and sometimes every time when there is something new, there can be some resistance. And also, for example, problems that we had with the Google glasses or things like that, people are reluctant, and even, maybe they think, what are you going to do to me with this? And I think we need to be very careful with privacy, with security and with all this that makes people believe that our networks, our technologies are safe, so they can be accepted from the first moment.
Petar, you raised an interesting point on devices in the previous question. Is that related with the things that we need to believe in your vision?
So there were many good things that were said already about energy consumption and data and so on. So when we look back, probably from 2030, we'll say, how could we use so much energy? It's like looking to the 5 megabyte memory from 1950s, right? When we see this big truck with the memory, we say, how could they make it so big? So probably with the energy consumption, will be like that. But one thing that I wanted to add is that right now there is a craze about AI training and using AI everywhere. But at some point, AI will become black boxes that we are integrating our systems. And then I think the challenge will be how to integrate in the systems. Right now, we are certifying certain protocols, algorithms like state machines, and we accept them in the system. With the black boxes, it will be more like interviewing employees. You know, we don't certify our employees as a state machines, but we believe the best in them, right? And we interview them. So I think we are going to move a little bit in that direction. So in the coming years, we have to understand how to assess and integrate these black boxes in our systems.
Thank you. Stefaan, this kind of forward-looking regulations, from a regulator perspective, are starting to be in the discussion? So, on AI is clearly one example.
I will not touch the technical part. There are people here who are better placed than I am. On the regulatory side, if I look back, okay, every country had very successful auctions. They gained a lot of money, but it took us more than 6 years to really attribute all the spectrum, which means that there's really some delay in countries. So I think we need to organize this, that it's faster and on a shorter time frame. I think that's one of the challenges that for 6G we certainly have to meet. And as already said here, security, privacy is a big one. So how this will look over 10 years, I think we will need completely new systems also to control it. And the same for a regulatory framework. What will happen in 10 years? If we want 6G to succeed, we need to be able to provide a stable regulatory framework also, so everybody knows the boundaries in which they have to work, but it will not be the boundaries of today. So we really need to have a forward-looking there, and actually, as a regulator, also do innovation and research on how that framework should look like. And at this moment, this is also not clear. So we will need to have their sandboxes with regulatory scenarios and see what happens there, and also have a trial and error approach, I guess. But at the end, we need to come as soon as possible with a stable framework there. Then more to the socioeconomic. Again, I think we will expect from the sector a huge investment to come up with this new technology. We still need to be sure that all the people will have access to it. So being able to offer this at a reasonable price certainly will remain a big challenge in the future also. And perhaps to continue on your resume on acceptance of technology, we had a lot of discussions. At a certain point, 5G caused COVID, birds died, I don't know what all diseases started. But now with 6G, we will have much more antennas, much more frequency used, a higher bandwidth. So the fear will only be bigger. And we need to, I will not say contain it or control it, but we will need to be able to communicate on that and to take that fear away. And for that also, we will need studies and a very clear and transparent communication. I think that's very important for the future.
Mm-hmm. Now I have a question for Huawei and Nokia as the leading vendors operating a huge share of the networks that are installed around the world. On your roles, how do you balance when you are evaluating a research project that needs to, in the future, be implemented in this case, in a product that is going to come to the market? I guess that when in one stream, you have a lot of hypotheses, assumptions that you have to prove, and by definition, research is uncertain. You have, let's say, high risk in that. But on the other, you have to, in a way, comply, I guess, with internally. You have also KPIs that you have to comply in terms of actually products that make all the cycle. So how do you balance these two realities? What kind of logic do you use to make the assessment on this? Any of you, both of you actually?
I can start. I think when it comes to technology development and prediction, you always have to have your mind ahead of time. There are the things that you can start with some assumption that something is going to be available, try to build on top of that. For example, if you look further, there was talk about the processing and energy consumption. Think about the neuromorphic computing, then you need to actually spend a little bit time on that because there is actually possibility to reduce a lot of energy, and that chip is actually well suited for the AI workloads. So portioning your research such that really for the long term, things that you think it can facilitate some of the key questions that we know is going to persist, and we have to find an answer to that. At the same time, you have to have the other part of the spectrum to have your foot in the reality to see what is the situation with the network today, how much digitalization you can do right now, how much data you have available, where are these data. So kind of balancing in these two extreme, but also in between, what are the availability and what are the components that you can already integrate with your product. So do whatever is possible in this middle ground, but don't forget the legacy and also the very long-term research. That's the way I see the balance.
So research-wise, it doesn't matter in what stage you have to invest long-term, mid-term, and near-term. So the matter is how to balance this. In terms of a long-term research, I think the industry is not the main player. So the academia is like theory and foundation work. In this time. So we have investment and the team to do this, but it is this is the ecosystem collaboration is very, very important. And then in the midterm, that means because we are like a standards-based industry, so that in that part, we have to contribute the technology to have to make the ecosystem of standards. So there are two-way standardization and software open source. So these are the midterm research outcome will come to. And then near term is the quality of your service, your product to the customer. So that's where you need a lot of technology investment in to get a competitive or high value to the customer. So that's the more or less the way of the putting the money. But we from industry see the research methodology also dramatically changed. We used to use chalk or pencil to derive the formula, compute things, and then we have a lot of computer is better. And now the tool is more powerful, so that the new methodology actually will be amplify your research outcome or in terms of your scope. So you won't be surprised if AI can prove some or discover some conjectures or prove some math conjecture which is unsolved for 100 years. That will come. So that's where there's no ending on the research.
Okay, now moving to the academia representatives. How do you foresee the collaboration with the industry? What things could be done to improve this virtuous cycle between the academia, as has been mentioned at the initial stages, in which maybe low TRLs are tested and the progress towards commercialization. It's a long process, but do you feel that there are things that can be improved? And we have, I think, a big audience today that probably are in this space in between academia and early stages of development. What do you see?
Would you like to start? Or? Okay. So what I think is missing is some bridge between the researchers and the part of industry that is working on standards. Yeah. And this is extremely important because if things don't go to the standards, they become irrelevant. And we don't really know how to reach to the people that are doing standards. I don't know if they read our papers. Probably not, because maybe they need some other way of explaining what we do that, I don't know. And maybe they also don't come to our conferences because these are very technical. So, but we also don't go to other events where maybe this is discussed. And it is not that we, people from academia, should attend the standards bodies. I don't think so. I don't think it is our role. But there must be a way, if I have some ideas of whatever new technology for 6G, how can the people that are going to standardize know about it? So maybe we need some kind of fora that are similar to this conference, maybe, but I don't know, where actually all this is cross-fertilized, and also how can I know what are the problems that are really relevant? Because I can know what are theoretically challenging and interesting, but I would like to be more useful in the sense that, well, in the standard we need this. And I think this is still missing. We have like two worlds that are a bit separate, and we need to find a way to converge.
Very good point. Petar?
Yeah, maybe a bit additional perspective on this. If you look 10, 20 years ahead, the question could be how companies and universities could change. And currently there is a reform in Denmark where the government decided to cut studying place at universities because they are missing workforce in terms of carpenters, electricians, and so on. So they're going to finance those educations. So what this tells us is that the companies and the society are eager to hire more people, and then the university will be pressured on funding because there will be less students coming. This probably will happen in other countries. And I think we have to think into interplay between companies and universities, meaning that the companies might take the students earlier as their employees, and then they get into a process of lifelong learning, where the role of the universities will be to provide this education together with the work in the company. On the other hand, the companies, many of them, not maybe Nokia and Huawei, but many companies actually are cutting on R&D. And they see maybe the university as a place where the R&D can take part, right? So maybe in the future we are going to see more shared positions of people that have university position and research and take part in a company, and which is kind of compatible with this eagerness for workforce. I think the thing with the workforce will not get better because we are below the reproduction rate of 2.1 kids per family. So I think there will be more hunger for a workforce, and this will change both the companies and universities.
One question to Stefaan on investments. Looking at R&D from an investment and not as a cost perspective, what incentives can be created by let's say, the public authorities, regulators, in order to incentivize the private sector to increase efforts in R&D? Do you have ideas?
Well, the easy and perhaps the answer you expect is subsidies, but I don't think that's a solution, to be honest, because as I see it for the moment, that's not working. What actually needs to be happen, I think, is really go to the real decision maker in the company. And what does a real decision maker want? He wants to make profit. So you go to an enterprise and you really have to come with use cases and not just only say it's better, it's faster, it's more reliable. That's fluffy, that says nothing. It's really calculating what's the profit for them and bring that on the table. And then you have decisions, and then they will move forward if they have a decent return on investment. Now, of course, with new technologies, the early movers, their business plans are not so good. And there I think that there's room for support from the government on buying equipment, on additional research to improve those business plans. But there first need to be out of the industry a real concern and demand and a business case before we should undertake something else. And that's what we perhaps see now. We have programs where we give tens of millions, and then everybody starts looking for a project so that they just have the money. But when the funding stops, the project also stops, and the result is almost nothing. So I think we need to reverse that process a little bit, and it's really convincing the companies, but for the reason of being, it's showing them the money. I think that's a very important one there.
I wanted to follow up on a question on AI, because it's also one of the topics of the discussion. I think you have a very interesting keynote tomorrow on AI. I don't want to do a lot of spoilers on your question, on your panel, but can we see AI as an opportunity to connect better the technology push and the market pull? Is there a role for AI to play a role there, in your opinion?
Technology, yes, but market-wise, so far, the AIs, the latest AI, need to prove, what they bring to the market yet. As a tool, it's for sure it will prevail, but as like a revenue generating or even profit generating, these are not really clearly demonstrated yet. Not as clear as a mobile internet at that level, but they are on the same order of magnitude. If it is not bigger, that's what the current assessment.
Okay.
I actually have a little bit of more faith on AI and possibility for that. We actually had a demo on the floor about natural language network. Yep. So you can actually, using the LLM, talk to the network. Yes, we are at the earliest stage of that, and even if we can do something today, we just think about a couple of years from that. I think anything that we can do for the end user to create a better experience will help. Creating, I think, the application of the digital twin already, we see how much it facilitates. Yes, I agree, it is still a tool that helps us to predict how we can actually adapt the network and application, but it actually impacts because it really helps you right away to know what this entity or this enterprise want from the network, and I can do a better service. So I think there are already many cases that we see the immediate impact of it.
On that line, do we think that AI is a very abstract term? It means many things for many people. Yeah. Do you think AI could be the killer app of 6G, and talking about having a very clear identified killer app, or is it too early to say? What do you think?
I think the AI is one name for many things. So I think if we look at it as an application, maybe some component of it is application. Yes, if the algorithm, if you refer to AI algorithm as a specific workload, yes, that could be considered an application, and it's really important for the network, especially if you, for example, think about federated learning and distributed intelligence. Yes, that could be a relevant application. But then there are many other things you can have under this umbrella of AI that not necessarily application for the network.
Okay, thank you. And going to Anna and Peter, when we were preparing for this chat, we were discussing what, in the context of, in the era of AI, what would be a standard, and how that is going to affect in the world of open source and AI. So how do you see the process of standardization? And we had very interesting discussions this morning on standardization. How do you see that evolving? How that is going to affect the industry?
I think standards need to be a little bit more flexible, but I don't think we need a lot of changes, because the way the standards are done by now, I think it was a very clever choice. Usually you don't standardize the procedure, but you standardize the signaling. And AI can work with the same signaling, or maybe we need to add additional signaling, but still the algorithm is not standardized. It doesn't matter if it comes from an artificial intelligence or it comes from a classical one. So maybe we need a little bit more flexibility because, for example, I'm thinking of the physical layer or where I'm happy in this world, right? So maybe you need a little bit more flexibility because if there is a machine learning that is going to come with, for example, a particular modulation or a particular coding or a particular MIMO scheme, you should be able to accommodate this among the choices. And usually the choices in the standard are very rigid and you have a few of them. So maybe we need to find a way to have more choices, but a little bit more flexibility. But in general, I think the way the standards are planned are very robust to becoming AI-driven. I see AI more as a tool than as an application. I think probably, as you were saying, right, the application will use AI, but it has to have something else, not just pure AI. And the same for the network, and the same for even the RAN, right? AI will be a tool, and we need to be able to use it as much as possible. But I don't think the standards need to be changing a lot, fortunately.
Petar, what do you think?
So currently, in a nutshell, the standard is describing some state machines and then some messages, how they interpret it, right? And these state machines and messages are defined by humans. But on the other hand, we have this other concept of modularization and layering, where you define module, and as long as the interface is followed, it can be implemented in the system. That's how internet scaled, basically, because it was decentralized, developed system. So the question is now, when will we accept a certain module to deliver its functionality within the network? So obviously, we have to have ways to test this and verify it. So maybe it will not be the same tools like protocol verification, but it will be, for example, conformal prediction or other statistical tools where we say this is good enough to be part of the network. On the other hand, we have to have the elements of explainable AI. We would like to understand how protocol behaves and how it will behave in a given situation. We don't want the abrupt stop of the protocol and so on. But if you let the AI develop language between them, then there could be a protocol layer that develops a protocol that we cannot understand, right? Because they figure out compressed messages and so on. So I think we need to understand how to control and verify this process rather than just specifying the messages and the state machines as we do now.
And Stefaan, from a regulator perspective, what are the areas where you are focusing on in 6G? What are the big discussions that you have in the board meetings where, I don't know, do you start to discuss 6G already at a board level of a regulator, or is it still early stages?
Well, we don't talk yet about 6G, to be honest. But we like to look at it in the future. And if you ask me what we will need to do there, it's what I already said. We will need to provide a stable regulatory framework, and we also will have to do innovation around it. An important role that I see for us here, and that I also have heard here, is really bringing the ecosystems together and be there a little bit the link between the academics, the industry, and really kickstart those ecosystems. I think that's important, and that's what not has been done enough within 5G. But at a side note, and now I don't talk as a regulator, but just as part of a public administration, what I think that we also need to do as public administrations, we are very good in telling what academics need to do. We are very good in telling what enterprises need to do. They need to innovate. They need to invest. But most of the time, all those administrations are standing at the side. And it's 2 years ago, I'd done a repository on 5G use cases. Almost none were done by public administrations. So I think that's a big challenge also for all administrations. Start also thinking on applications, on use cases, and make those also happen. And only by doing that, we will create a critical mass also to kickstart some things. And because what we see now in a lot of discussions, it's the chicken and the egg discussion. And perhaps also that approach could bypass that. I think that's something we also need to work on. I'll be happy to address that point in the Belgian administration.
Maybe it's a good opportunity. We have, I think, 10 more minutes to open the floor to the people that are attending today the session. I don't know if there is any question that anyone would like to ask to the panelists on this topic. Not sure. No questions? Yes, we have a couple of mics in the room.
I think that from the conversation and for what we see, it looks like that in the future we don't need a standard. In other words, if you put a system that can write the code for himself, and can learn the network for different environments, for each environment there is some kind of intelligence that will take the code, change it a little, tweak it a little, but it will be going by himself. So if a user is coming, doesn't have the software for the user, it can be a reference, a connection between them, how to connect first in the beginning, but then the base station can download the software to the user and is in the network. So maybe in the end, maybe we don't need a standard, and all this headache that the standard is taking like 10 years to come up will be like a few minutes.
I don't know if we want to take, this is part of the discussion that we have to prepare this panel, but who wants to take it?
Yep. I can take a little bit. This is a very good question. If it is not near future, in the future, yes, they will understand intelligently. As long as you can interoperable with any objects, there's no need of standards.
Yeah,
Petar?
I just want to make a quick comment. I agree very much that when we talk about the fully autonomous system, that's what we expect, that the system at certain level. But within that system, if everything is happening and is a boundary, then yes, you don't need to talk to anybody else. Then you don't need to be having a standardization. But then comes the question of, I think, the good comment you made earlier about the regulation. Where is the level of autonomy and what will be the boundary of autonomy that we want to have? Maybe we don't want to have any boundary, I don't know, but that will be a good discussion for the regulators to have. But yes, full autonomous system within that boundary doesn't need to.
Yes, of course, Petar.
So we might not need the standard, but we can probably define something that is a meta standard, right? That defines what this software has to do and how it defines their own protocol. Because we cannot have a situation where a device is using stealing spectrum from the others and so on. So we have to define the rules of behavior for how that autonomous software will run. So some form of meta standard will always exist, in my opinion.
Yeah, and I think if you really need devices from all over the world to be able to communicate, I think we need standards. I mean, I see it very, very far in the future when perhaps a machine with the other machine can agree completely on the way they are going to communicate. Even at least we should standardize what kind of machine learning they are using, because they could arrive to different solutions and never communicate. I think it's still we need a lot of standards, which are good. I don't think they are bad. It's just we need a little bit of flexibility, a little bit more of understanding, but I think they took us to where we are, and I think it's a good thing.
5 years from now, might be no need of standard, and this is exactly 6G.
This totally.
And regarding regulation, you can teach the AI machine the regulation that you want, but that's not the standard. This is a regulation like the unlicensed regulations and these kind of things, if you want to control it. In the unlicensed environment, everybody can do whatever you want according to constraints of the unlicensed. You can teach the AI the similar things, and that's all. And then from there, we can move forward.
I think 5 years is too short. You say in the unlicensed, they do whatever they want. No. Two devices that are communicating in an unlicensed spectrum, they both know, and they are doing the same. Maybe the others are doing different, but the two that want to communicate, they need to agree on how they communicate. I really see it very far away in time.
That's what I said. There is a common language that everybody knows to talk to the other. Let's say a reference to 5G. And the user is coming to a new network. He knows how to talk to the base station. He knows how to download the new software. And from there, it's continue.
Well, I think the point is clear. I think different opinions in the room. Probably collaboration is going to be relevant in the future. Interoperability is going to be relevant, and maybe I think maybe there will be a different type of process for a standard to be created that will be more dynamic. But I think I tend to agree that probably we will continue needing some kind of alignment on at least on basic things. One thing related with that is on the collaboration with the verticals that has been identified in multiple conversations as maybe one of the lessons learned of 5G, that the verticals were not involved in early stages of the definition of the system. Is that different in 6G? Are you working already with verticals to try to understand? I think it was your point before, Anna, what they need really, what is the pain point, how to address it, or how are you working on that?
Yeah, so vertical was the early vision of a 5G, and the Horizon program, that was I think that was the first one to put a vertical as a research program, and we have created 5G AA, so that is the mobile industry, the car industry, and the 5G ACIA, and some other consortiums as well. So that exercise is useful. First of all, the vertical on those sectors start to believe a standardization before they don't. They don't even talk among themselves. So this is a cultural change. It will happen, and it's because it's slow. The 5G vertical private network in China end of last year is about 22,000. So I think right now should be 30,000 already. So, but it's a slow. In terms of a total market is about 5% compared to the consumer market, but it's happening. Because those people, when they are using the 5G technology, it does improve their productivity.
Yeah, I like to comment on the fact that if you want to engage with vertical, I think it has to go beyond the conversation in a room. You actually have to experiment with something. And if you want to know what is it that 5G can do, you should have the basic of the 5G already implemented, so you can actually do further exploration. But I wouldn't say that there hasn't been any engagement with vertical during the 5G and prior to 5G. I think as soon as we knew what the shape and format, even the POCs were ready, even pre-standardization on the 5G, there was already experimentation with vertical. But I like the comment you made about the odd even. So a lot of learning that has come with the engagement with vertical are starting to solidify, that you can see some of them maybe needs interoperability within one industry, within one enterprise, or maybe across all the enterprise. But all of those learning are there that are a solid base for the 6G.
Talking about the collaboration with the verticals, there is a discussion on talent and on their future roles, and I think we also discussed this where do you see the gaps? In order, I mean, do you when you have to interact with a vertical on things that are really frontier in terms of technology, do you feel like you have the right interface at the other side that understand what it means for them to work on these topics? What is your experience?
So I think when it comes to vertical, of course, you need the domain knowledge. Since we are representing research, at least I'm representing research, to find those talented research individuals that are willing to learn about another vertical, another domain, is a bit rare, but is not impossible. So we actually have fantastic people that are really getting themselves excited about understanding the entire mine. And one of the demos that we had was actually the example of it. But then also, if you go there at the beginning of it, maybe the conversation, it doesn't flow, but the moment that you learn each other's language is very rewarding exchange for both sides. And there are more and more researchers that they want to do experimentation, they want to be in dialogue with the vertical. And we are learning also what it is that needs to be the base of conversation. So those are starting to become easier. Yes, at the beginning, very beginning, the conversation with vertical is like alien. We don't know each other, we don't know how to talk, but I think it's getting better.
And Petar, from your experience at the university, where do you see opportunities to maybe to do something different or to organize activities in a different manner? On talent, I mean.
Should I take?
So you mean with the verticals?
For example.
Yeah. Yeah, I think the projects that are being presented here are very important because you need to consider the end user, being it the people or the verticals, from the very beginning, because you need to understand the requirements. Otherwise, it will be useless, right? I saw a lot of people attending that come from verticals and wanted to know what 5G can offer and how can I use it. So I think it is extremely important to have this, not only conversation, but even projects where you show how 5G or 6G can help. Some sectors are a bit reluctant to changes in technology, and those are usually the ones that can benefit more. So we need to make an effort to make them understand. For example, we sometimes work with construction companies, and yes, these are really, slow in changing, but then when we show them how more effective the construction of a tunnel can be with 5G or visible light communications or these things, they really realize how much this can help. Yeah.
Petar, do you have any insight to share?
Yeah, maybe some short opinion on this. The person that invented the transistor, Shockley, he was a physicist. Mm-hmm. And then at some point, the transistor became domesticated, became a part of a block diagram, and then the engineers took over, right? So the question we can ask now is what are the new block diagrams that are created that the future profiles should work with? One is, of course, for the vertical industry, that box will be communication engineering. But for communication engineers in the future, there are at least two candidates for new black boxes. One is, of course, the AI that will become a tool, so our future engineers should know how to integrate this in their system. That's the new transistor. And most likely the quantum circuits, because they also will be part of some block diagram.
Mm-hmm. On going back to verticals, I'm interested in Huawei is doing a lot of work in automotive. And you are collaborating with some OEMs. I found very interesting the collaboration model. What is? How do you have joint research? How do you manage this type of relationships?
So that is one example that we start to get into the car domain. Let's say maybe less than 6 years. Mm-hmm. But the base technology are all available inside the company. So when this opportunity show up, that's where we can assemble. So there are two things that we offer. We don't do the whole body of a car, but we offer the whole intelligent system. That means the same operating system to do everything in the car. So that's one big user experience needed. So it's an integration, and there will be the inside other cars solution. And second is autonomous driving. So that's the second aspect. So far, this business is staying Huawei or it's not staying Huawei, we're not finalized yet. So it may be one day they will build the complete car and become a car company, but then it will be, it could be also become a joint. Those are the business model. But in terms of base technology, it is the software, hardware, very complex, and because it's capable to do this.
I was interested just to know if who approached who. Huawei approached the OEMs, or the OEMs approach Huawei. How do
there's one of the business opportunity experiment, exploration. So we first invest the technology, and then I think the key critical point is the EV become truly take off in China. So that's where these two make business sense now. Otherwise, it will be an incubation format.
From a Nokia perspective, do you have other, verticals? I've seen some demonstrations outside on, for example, on immersive reality. Do you have a kind of established relationship with certain verticals?
Yeah, I think from the early stage of the research, we start engaging with vertical whenever applicable. Of course, not all the research is really applicable to experiment with vertical, but we actually, Nokia has the enterprise branch that they are working closely with different vertical, and actually we have the product to offer, and that will be easier because then there is something already that you can experiment further on. And I think those are becoming more and more reliable context that you know that there is a trust level, but also there is a component that you can experiment. Then you find new use cases and new possibilities.
And from a university perspective, when you kind of do your research project, do you have any vertical in mind, or a specific one in which you somehow use as a reference, or how do you organize yourself?
In my case, we work very much in the physical layer, so not really having any particular vertical in mind, but just trying to provide enabling technologies that will facilitate all types of communication. And at the moment, of course, we need to focus a lot on the integrated communications and sensing. This is not looking for a particular vertical, but I think it's going to be essential if we really want to do immersive communication. That is going to be what, you have mentioned that it seems that verticals can benefit a lot from it, right? So long range, ubiquitously, high speed, joint communications and sensing. This is like the techniques we are working on, and for sure they will be needed, but we are not specifically looking at a particular application in my case.
Petar, do you have any kind of favorite vertical when you...
Yeah, we collaborated with people from medical and rehabilitation engineering. Usually they call the wireless thing, they call it Wi-Fi or Bluetooth. So the question is usually, what do you want from Wi-Fi or Bluetooth? And then we translate it into 5G or 6G, right? So, the awareness among the other verticals is not that high about these people would prefer to use some accessible technologies like Wi-Fi or Bluetooth. But it's actually good to talk to them to see what are the actual requirements, whether this 1 millisecond is really needed or we can do something else. How do they assess reliability, for example, of the overall system? And that can kind of give inspiration what we could do in a comm systems.
And from, in this case, a Belgian perspective, do you have any specific vertical this morning? When I was attending the opening, there was a very interesting presentation on the port of Antwerp, which I think have a very advanced 5G network, and they have a lot of automation already included. Do you have any specific kind of vertical, in this case, in Belgium?
Yeah, well, as you say, logistics, the ports, also for the airplanes, we have already private networks. So around that sector, we certainly are already well developed. We had big plans around smart cities, to be honest. I don't see happen there a lot for the moment. So it's actually in manufacturing and in logistics that for the moment we see most movement around 5G. And I guess that will be more or less the same for 6G in the future. We also have very good projects around healthcare, but they are still in an initial phase, I think, that still need to be further developed. There we need to build up still some trust on the technology.
Okay. I think we are running out of time, and I think we can probably close here. I just want to remind the audience that tomorrow I think we will have keynotes of Dr. Wen, and tomorrow is also Petar. You are also tomorrow. And on Thursday we have a keynote with you and with Stefaan. So we have here the 5 keynote speakers of EuCNC this year. So I really would like to thank you for your participation in this panel. You have been very helpful in the preparation. And really, I think with this we can probably close the day, and I suggest that we thank you with an applause. Thank you. Thank you very much.